The purpose of this PowerPoint is for you to attempt to complete a past paper question. It's split into 3 different sections. In the first section, you're going to be given the exam question, and the aim is that you just try it on your own and you see how far you can get through the past paper question. Hopefully you'll be able to do it all on your own. If you find that you're struggling, then you can move on to section 2, where I'm going to give you a few little hints and some tips on how to perhaps get started, so then you can have another go at the past paper question. And if you're still totally confused, then you can move on to section 3, where I'll go through the whole question in lots of detail. Okay, so here's the past paper question on functions. It asks you to find the range and then the inverse. So press pause now and have a go at this question on your own. If you need some hints on how to get started, then I'll do that on the next slide, but you should definitely try it on your own first. So press pause now. On this slide, I'm going to give you some hints. You should only be watching this slide if you've tried the question on your own first. Right, some hints on this one. So first of all, let's talk about these important words, domain and range. The domain and the range are just fancy words for inputs and outputs. So we're given a function and they're telling us that for this question, the numbers that you're allowed to put in are any x values that are less than or equal to -1. So anything from -1 and downwards, lower, you can put into this function. So that's what they're telling you you're allowed to put in. When it asks you to find the range, it's asking you what could you get out. So what I would start thinking about is I would start with that -1. You can put that in and see what you get out. And then start investigating some lower numbers underneath -1. Start investigating what you might get out if you put in lower numbers. You could even go down as far as thinking about -infinity, which of course is the lowest number. And imagine putting something that was really small, like -infinity, into there. Try and work out what you'd get out. And then once you've worked out what you think are all the values you could get out, see if you can find a way of writing them down. You can use the inequality notation, like they've done in this question, but don't forget you can also use bracket notation. So that's question A. In question B, it's asking you for an expression for the inverse. So that means you need to rearrange it. So what I would do on this question is start with y equals x plus 1 squared minus 2. So just copy the function from the question, put it equal to y, and then rearrange it. Because when you rearrange things, you're doing opposites. So if you took the -2 over, you'd make it a +2. So we're doing the opposites, we're doing the inverse. So rearrange to get x on its own, and then that's going to help you to know the inverse function. The last bit that it's asking you for are the domain and range for the inverse function. But don't forget that the domain and range for the inverse function will be the same as the domain and range from the original function, but just swapped over. So if you know the domain and range for the original function, you automatically know the domain and range for the inverse. All you've got to do is swap them around. Right, press pause now. Have a go at this question again now on your own. Only go on to the next slide as a last resort. Really try it on your own first, and if you really can't do it, then watch the next slide. Okay, so I'm now going to go through this question in detail. You should only be watching this if you've tried the question on your own, so if you haven't, press pause now and have a go. Now in part A, it gives us a function and it tells us the domain. The domain is just a fancy word for input, so the numbers that you were allowed to put into that function. And then it's asking you to find the range, which is just a fancy word for the outputs. So it's saying if we put in numbers lower than or equal to -1, what could we get out? They could have given you that domain in bracket notation, and sometimes they do. So let's think about what that would look like in bracket notation. This is from -1 downwards, down as far as -infinity. So we could have written it as this, -infinity up to -1. And notice that I've put a curved bracket on -infinity. because a curved bracket means you don't include that value, and we can never include minus infinity because we never quite reach it. But then I put a square bracket around -1 because a square bracket means you do include that value. And because the inequality said less than or equal to, I needed to put the square bracket to show that it could go up as far as -1. Now those are my inputs. The question is, what could the outputs be? So I need to think about, if I put in any number between minus infinity and -1, what could I get out? And in particular, what's the highest number I could get out and what's the lowest number I could get out? So you could start off by putting -1 into the function. I think that's helpful, putting in -1. So if we put that into the function, it would say -1 plus 1 squared take away 2, which is -2. So putting in the highest value that I was allowed to, I got an answer of -2. Now I'm going to start thinking about what would happen if I put lower values in. So if I put lower values in, what sort of answers would I get? Now the lowest value I'm allowed to put in is I was going to say minus infinity. I can't actually put in minus infinity because minus infinity is not a value, but I can still think about what the answer would look like if I did put in minus infinity. So let's write it down with minus infinity in and see what sort of answer we think we're going to get out. So if I put something really tiny, a negative number that's really, really negative, and I add 1 onto it, it's still going to be really, really negative, really low negative number. Then if I square it, it's going to jump to be a positive, because a minus times a minus is a plus. So this will turn into an absolutely massive number. It'll turn into positive infinity. And when you take 2 off that, it's still going to be infinitely big. So this is going to tend towards positive infinity. I won't write equals infinity because that's a bit naughty. I'm not going to equal infinity, but it will tend towards positive infinity. So I can see from here that the lowest value I would get would be -2, and the highest value I would get would be infinity. So I'm going to write my answer in bracket notation. I'm going to put a -2 and then an infinity. Remember that with bracket notation, we always put the lower number on the left and the higher number on the right. I've put a curved bracket on infinity because we always do with infinity. You can never reach infinity. But I've put a square bracket on -2 because in this question I can get the exact value -2 out by putting in -1, and I was allowed to include -1 from the domain, so I can get -2 in my answers. Now there is another way of thinking about this, and that is to draw the graph of the function. If they give you one that you know what the graph looks like, it can be helpful. It's not necessary, it's not something you have to do, but it can help if you know what this graph looks like. Now this one is a quadratic curve, it's a U-shaped curve, and I need to move it 1 to the left and down 2. So the quadratic curve would look, that's terrible, let's try again, it would look something like this. With that minimum point there would have an x coordinate of -1 and a y coordinate of -2. And when it's asking for the range, they are acting like our y coordinates. Inputs and outputs are like x coordinates and y coordinates. Well, if you look at this graph, if I look at the whole of the graph, the lowest y coordinate that I can see is -2. That's the lowest point that it goes to. But then the highest point that the graph reaches is infinity, because these curves would keep going up forever and ever. So -2 to infinity. Right, moving on to part B. Find an expression for the inverse function. F minus 1 means inverse, and state the domain and range of the inverse. Okay, I'm going to do this part first because it's easy to do, and I think it's going to help to find the inverse function. So I'm going to write down the domain and range first. Now these are really easy to do because we know the domain and range for the original function. With the inverse, we copy them, we just swap them around. So earlier on, the domain was, I'm going to use the bracket notation, minus infinity to minus 1. So that now becomes my range, minus infinity to minus 1. The range in part A was minus 2 to infinity, so that now becomes my domain. So I've written those two down first because I think they're going to help me with the rest of the question. Right, so now I need to try and find this inverse function. So the way that I find the inverse function is to, first of all, copy down the function from the question, but write it as y equals. So it was x add 1 squared minus 2. Now I want to find the inverse. That means I need to rearrange it, because when you're rearranging something, you're doing all the opposites. So for example, if I took the minus 2 over, it would become a plus 2. So by rearranging it, we're turning all of the operations into their inverses. Now the next thing I would do is square root both sides, because that's going to get rid of the squared. My aim here is to get the x on its own, make x the subject of the formula. So I've square rooted both sides, but I need to think carefully now about whether it's the positive square root or the negative square root. Now, the outputs of this function, if you look here, the outputs, the range of this inverse function have to be negative. So the only way that I'm going to make this have negative outputs is if I take the negative square root. And that's a step that I would expect a lot of students would fall down on and would miss out. It's quite a tricky step there to realise. But I'm going to have to take the negative square root, because that's the only way that I'm going to get these negative outputs. And then my last step, of course, would be to take the 1 over to the other side to get the x on its own. So I'm going to write minus root y plus 2. And then if I bring the plus 1 over, it becomes minus 1. So my inverse function, f minus 1 of x, I know the answer because I can use this inverse. The only problem with that bit in yellow is that it's written in terms of y. I need it in terms of x. So I'm going to write it as minus root x plus 2 and then take away 1. So there's my final answer for the inverse function. And like I said, the tricky bit there would be to realise that you have to take the negative root, because that's the only way you're going to get negative outputs.